Welcome to UXL, where you can learn new skills anytime and anywhere. Visit uxl.com to explore our full course selection. This lesson is part of a larger course. Check the video description below for a link to the full course where you can enroll. If you enjoy our content, please like and subscribe. For your convenience, the course cover displayed on your screen provides the complete course title and lesson title. Let's proceed with the lesson. Lesson: Advanced VPC Configuration. Advanced VPC configuration is a crucial topic for any aspiring AWS certified cloud practitioner. Amazon Virtual Private Cloud allows for the creation of a virtual network within the AWS cloud, providing full control over the network environment, including the selection of IP address range, creation of subnets, and configuration of route tables and network gateways. Understanding advanced VPC configurations is essential for optimizing network performance, security, and management. One of the fundamental aspects of advanced VPC configuration is the segmentation of networks through subnets. Subnets are subdivisions of an IP address range within a VPC. Using subnets allows for the separation of different types of resources, which can be placed into public or private subnets based on their accessibility requirements. Public subnets are associated with a route table that has a route to an internet gateway, enabling instances within these subnets to communicate with the internet. Conversely, private subnets do not have a route to an internet gateway and are used for instances that should not be directly accessible from the internet. This segmentation enhances security by limiting the exposure of sensitive resources. Network access control lists and security groups are critical components in controlling traffic flow at the subnet and instance levels, respectively. NACLs act as a stateless firewall for controlling inbound and outbound traffic to and from subnets. Each NACL rule is evaluated in order, starting with the lowest rule number, and continues until a match is found. Security groups, in contrast, are stateful and operate at the instance level, allowing for the specification of permitted inbound and outbound traffic. The use of NACLs and security groups together provides a layered security approach, significantly reducing the attack surface of your VPC. Route tables play an essential role in defining the paths that network traffic takes within a VPC. Each subnet must be associated with a route table, which contains a set of rules, called routes, that determine where network traffic is directed. By default, AWS creates a main route table for every VPC, but additional custom route tables can be created to control traffic flow more granularly. For instance, you might have a route table with a route directing all traffic destined for the internet to an internet gateway, while another route table might direct traffic to a virtual private gateway for a VPN connection. This flexibility in route table configuration allows for sophisticated network architectures. Elastic IP addresses are static IP addresses designed for dynamic cloud computing. Unlike traditional static IP addresses, EIPs can be remapped to another instance within the same VPC, allowing for high availability and fault tolerance. EIPs are particularly useful in scenarios where an instance must maintain a consistent IP address despite restarts or failures. For example, if a critical web server instance fails, an EIP can be quickly remapped to a backup instance, ensuring minimal disruption in service. VPC peering enables the connection of multiple VPCs, allowing resources within different VPCs to communicate with each other as if they were within the same network. VPC peering is beneficial for organizations that require isolated environments for different departments or projects, but still need to share resources. It is important to note that VPC peering connections are not transitive. If VPC A is peered with VPC B, and VPC B is peered with VPC C, VPC A and VPC C cannot communicate unless a direct peering connection is established between them. Proper planning and configuration of VPC peering can lead to efficient and secure inter-VPC communication. Another advanced VPC feature is the use of VPN connections and AWS Direct Connect for hybrid cloud architectures. VPN connections allow for secure communication between an on-premises network and a VPC by leveraging the internet. AWS Direct Connect, on the other hand, provides a dedicated network connection from an on-premises network to AWS, offering lower latency and more consistent network performance compared to VPN connections. These options enable seamless integration of on-premises resources with cloud resources, facilitating a hybrid cloud strategy. The use of network address translation is essential for instances within private subnets that need to access the internet for updates or other purposes without exposing them to inbound internet traffic. AWS offers two types of NAT devices: NAT gateways and NAT instances. NAT gateways are managed services that provide high availability and scalability, while NAT instances offer more control and customization but require manual management for high availability and scaling. Choosing the right NAT solution depends on specific use cases, such as the need for custom configurations or cost considerations. AWS Transit Gateway is a powerful service that simplifies the management of multiple VPCs and on-premises networks by acting as a central hub for network traffic. Transit Gateway enables the creation of a hub-and-spoke topology where multiple VPCs and VPN connections are attached to a single transit gateway. This approach reduces the complexity of managing multiple VPC peering connections and route tables, leading to a more streamlined and scalable network architecture. Additionally, Transit Gateway supports multicast, allowing for the efficient distribution of data to multiple destinations. Flow logs provide visibility into network traffic within a VPC, capturing information about the IP traffic going to and from network interfaces. Flow logs can be used for security analysis, troubleshooting, and performance optimization. For example, flow logs can help identify unusual traffic patterns that may indicate a security breach or pinpoint network bottlenecks affecting application performance. Flow log data can be stored in Amazon S3 or Amazon CloudWatch logs, enabling integration with other AWS services and third-party analytics tools. VPC endpoints are another advanced feature that allows for private connectivity between a VPC and AWS services without traversing the public internet. There are two types of VPC endpoints: interface endpoints and gateway endpoints. Interface endpoints use AWS Private Link to provide private connectivity to services such as Amazon S3 and Amazon DynamoDB, while gateway endpoints provide a target for a route in a route table to access these services. VPC endpoints enhance security and performance by keeping traffic within the AWS network, reducing exposure to internet-based threats, and improving data transfer speeds. The cost implications of advanced VPC configurations should not be overlooked. While features like NAT gateways, Transit Gateway, and VPC endpoints offer significant benefits, they also incur additional costs. For instance, NAT gateways are billed based on the amount of data processed, and Transit Gateway is billed based on the number of attachments and data transfer. Therefore, it is essential to carefully evaluate the cost-benefit ratio of each feature and implement cost management strategies, such as using AWS Cost Explorer and setting up budget alerts to monitor and control expenses. In conclusion, mastering advanced VPC configurations is essential for effectively managing and securing network infrastructure in AWS. By leveraging features such as subnets, NACLs, security groups, route tables, VPC peering, VPN connections, NAT, Transit Gateway, flow logs, and VPC endpoints, organizations can create robust, scalable, and secure network architectures. Understanding the intricacies of these features and their cost implications enables cloud practitioners to design and implement optimal network solutions, ensuring the efficient and secure operation of their AWS environments. This concludes the lesson. We trust you found this video informative and engaging. To enroll in the complete course, please use the link provided in the description below. At UXL, we are committed to your learning journey. Each course offers a certificate of completion, online support, and downloadable resource files to enhance your experience. If you found our content valuable, we invite you to like this video and subscribe to our channel. Thank you for joining us, and we look forward to supporting your continued pursuit of knowledge.